universe just broke its own rules. Not gradually, not as a slow revision buried in a scientific journal. It broke them all at once, on a single night when a telescope, floating 1,000,000 miles from Earth, pointed its mirrors at a patch of sky so empty and so dark that astronomers used to call it a cosmic void. What James Webb found there wasn't nothing. It was everything we were told couldn't exist yet. Thousands of galaxies, ancient, fully formed, burning with starlight. In a time so early that the universe itself should have been little more than hot gas and scattered dust. No stars, no structure. Certainly no galaxies. The mathematics of cosmic formation said it simply was not possible. And yet, there they were, staring back through time like a message that had been waiting 14 billion years to be delivered. But the deeper you go into what Webb is actually revealing, the more unsettling it becomes. Because it isn't just one discovery. It's a cascade, each finding more disorienting than the last. Galaxies too massive for their age. Black holes that shouldn't exist yet. Structures stretched across hundreds of millions of light years that defy every model we've built. And beneath all of it, one question that Webb cannot answer, cannot even begin to answer, about what lies beyond the edge of everything we can ever see. That question is what this video is really about. To understand what Webb is showing us, you first have to understand what it means to look at the sky, not philosophically, physically. Every time you look at something, you're not seeing the present, you're seeing the past. Light travels at 196,987 miles per second. It is the fastest thing in existence, fast enough to circle the entire Earth 7 times in a single second. And yet, even at that speed, light takes time. When you look at the moon, you're seeing it as it was 1.3 seconds ago. The sun you see every morning is the sun as it was 8 minutes ago. If the sun vanished right now, we wouldn't know for 8 full minutes. We would stand in daylight that was already a lie, move further out, and the delay becomes staggering. The nearest star beyond our sun, Proxima Centauri, sits 4.2 light years away. The light reaching your eyes from that star tonight left its surface in the year 2021. You are watching the past. Andromeda, our nearest galactic neighbor, is 2.5 million light years away. The light leaving it right now won't arrive here until humanity has been gone for over 2 million years. The image of Andromeda you see through a telescope tonight is a snapshot of that galaxy as it looked before our species existed. The sky, then, is not a view of the universe as it is. It is an archive of the universe as it was. Every point of light is a different timestamp. Every photon a different chapter of the same impossibly long story. This is why the James Webb Space Telescope changes everything. Hubble showed us the distant universe. Webb sees it. There's a difference, and that difference is the infrared. Here's the physics. As the universe expands, it stretches the light traveling through it. The way a rubber band, when pulled, stretches everything drawn on it. Wavelengths grow longer, and as they lengthen, visible light shifts, first toward red, then beyond red, into the infrared spectrum that human eyes cannot detect at all. The most ancient light in the universe has been traveling so long, stretched so far, that it no longer looks like light at the wavelengths we can see. It arrives as heat. Hubble couldn't see that. Webb was built specifically to see nothing else. With mirrors coated in gold, the most reflective material at infrared wavelengths, and shielded behind a sunscreen the size of a tennis court that keeps its instruments near absolute zero. Webb can detect light that has been traveling for over 13 billion years, light that left its source before our solar system existed, before the Earth was even a thought in the mathematics of gravity. And when it looked, it found something that stopped astronomers cold. The first deep-field images Webb sent back showed more than anyone expected, not just more galaxies, more early galaxies, galaxies that existed 300 to 500 million years after the Big Bang, in a time astronomers call cosmic dawn. when the universe was so young it barely had enough hydrogen to form its first stars. These galaxies shouldn't have been there. Not that size, not that bright, not that structured. Galaxy formation takes time. You need gas to collapse under gravity, clump into stars, those stars to explode and seed the surrounding space with heavier elements, that enriched gas to then collapse again into new stars, generation after generation, until you have enough mass and enough structure to call it a proper galaxy. Our own Milky Way took billions of years to build itself into what it is. But Webb found galaxies that appeared to have skipped most of that process. Fully formed, mature, containing hundreds of billions of stars, comparable to the Milky Way today, in an era when the entire universe was less than 500 billion years old. Astronomers published papers, then they published corrections, then they published papers saying the corrections weren't enough. The models that predicted how galaxies form, models decades in the making, calibrated to match every observation Hubble ever took. Those models were under-predicting by factors of 10. A factor of 10 is not a rounding error. That is a fundamental misunderstanding of something. Then came the black hole, supermassive black holes, the kind that sit at the center of galaxies and can contain the mass of billions of suns, are supposed to grow slowly. They feed on surrounding gas and dust, pulling it in across millions of years, gradually accumulating mass like sediment building into stone. The most massive ones we know of took the entire history of the universe to become what they are. Webb found supermassive black holes at the centers of those same impossibly early galaxies, black holes with millions, sometimes billions of solar masses, already fully grown, already spinning and devouring matter at maximum capacity, in a universe that hadn't even celebrated its first half-billion years. There wasn't enough time. By every calculation we had, there wasn't near enough time for that much mass to have accumulated through any process we understood. And so, once again, the question, what did we get wrong? Some theorists think there must have been a seed, a direct collapse black hole, formed not from a dying star, but from the raw collapse of an enormous cloud of primordial gas, massive enough from the very beginning to grow into what Webb is now finding. That theory existed before Webb, but it was a minority position, a last resort. Now it's becoming mainstream because the alternative, that our entire framework for how black holes grow is incorrect, is even harder to accept. Except maybe it shouldn't be, because there is one thing Webb revealed that goes beyond galaxies and black holes. Something that operates at a scale that makes both of those things feel small. Astronomers studying the distribution of galaxies across the universe have long known that they aren't scattered randomly. Galaxies cluster together along vast filaments, threads of dark matter and gas connecting them, separated by enormous empty voids where almost nothing lives. This large-scale structure, the cosmic web, was mapped and modeled through decades of observation. It matched our simulations. The universe at its largest scales seemed to follow the rules. Then Webb revealed the cosmic vine, a structure of at least 220 massive galaxies, all connected, all located at the same extraordinary distance, stretching across 13 million light-years of space, seen as it was just 1.1 billion years after the Big Bang. A structure that size, that organized, that connected, at that age, should not exist yet. The simulations didn't produce it. The math didn't predict it. And it is almost certainly not alone. We are finding things we don't have names for yet. All of this, the early galaxies, the impossible black holes, the cosmic vine, arrives with a deeper implication that Webb itself cannot resolve. The observable universe is not the universe. It is only what we can see. Light travels at a finite speed. The universe has a finite age, roughly 13.8 billion years. So there is a horizon, a distance beyond which light simply has not had enough time to reach us. We call it the cosmic horizon. Everything beyond it is, in the most literal sense, invisible, not just faint, not just obscured, permanently unreachable, because the universe is also expanding. And at large enough distances, it expands faster than light can travel across it. Most of the universe lies beyond that horizon. Not some of it, most of it. Our observable universe is a sphere roughly 93 billion light years in diameter, already far larger than you'd expect, because the universe expanded while light was traveling toward us. But the total universe, cosmologists estimate it is at least 250 times larger than what we can observe. Some models suggest it is infinite. There may be regions of space that have been expanding since before our Big Bang. There may be entire histories, civilizations, stars, physical laws that have been playing out in silence, forever beyond our reach, in a universe that shares the same origin but no common future with our own. Webb cannot see any of that. What Webb can do, what it is doing right now with every new image, is push our observable horizon back further than any telescope before it. It is reading earlier chapters of the archive, resolving details in the ancient light that Hubble could only smear into noise. And in doing so, it is not finding a universe that was simple and primitive in its early days, slowly growing in complexity over time toward the richness we see today. It is finding a universe that was already extraordinarily complex, extraordinarily quickly. A universe that seems to have hit the ground running in ways we are still struggling to explain. There is a question astronomers ask quietly, not in papers, not at conferences, but in the spaces between certainty and theory, that Webb is making harder to ignore. What if our model of how the universe began is incomplete? The standard model of cosmology, the Big Bang, inflation, dark matter, dark energy, has been refined over decades into something that explains an enormous range of observations with incredible precision. It is not wrong, but it may be incomplete in ways we haven't yet recognized. The early galaxies might be telling us that inflation, the period of exponential expansion in the universe's first moments, was faster or more uneven than we thought. The black holes might be telling us that the conditions of cosmic dawn were stranger, denser, and more violent than our simulations capture. The cosmic vine might be telling us that structure itself forms differently when the universe is young and hot and dense in ways no model has ever fully captured. Or all of it might be pointing at something we haven't thought of yet. Science works like this, not as a smooth progression of answers, but as an interrupted conversation, long stretches of confirmation suddenly broken open by something that doesn't fit. Copernicus broke it open. Darwin broke it open. Hubble broke it open when he proved our galaxy was not the entire universe but one of billions. And now Webb is breaking it open again from a vantage point we've never had before, reading light that has been waiting 13 billion years to be understood. The images Webb sends back are not photographs in any ordinary sense. The telescope collects photons, individual packets of light, and reconstruct from them a picture of a sky that no human eye could ever see. The colors are translated from infrared wavelengths we cannot perceive into visible light we can. The scale is compressed from billions of light years into pixels. Every image is an interpretation, a translation from physics into something our minds can grasp. And yet, when you look at a Webb deep field image, really look at it, knowing what you're seeing, something shifts. Those aren't just points of light. They are entire galaxies, each containing hundreds of billions of stars, each star perhaps surrounded by its own planets. In an age so remote that the atoms in your body didn't yet exist, you're not looking at the sky. You're looking at the beginning of the story. You're still inside. That is what Webb is doing. Not just collecting data, not just testing models. It is extending human perception to a boundary that, until now, we could only calculate and never see. It is giving us eyes at the edge of time, and at the edge of time, the universe does not look the way we expected. So here is the question Webb cannot answer, the one that may never be answered, not by any telescope we could ever build. What is happening right now, in the regions of the universe we can never see, in the space beyond our cosmic horizon, there are galaxies we will never observe. Stars that formed, burned, and died before a single photon of their light could reach us. There may be intelligence out there, forms of life that look at their own sky and see none of ours, whose entire observable universe is one we will never know existed. There may be nothing. There may be physics different from our own, laws of nature that took a different shape when the early universe expanded into regions we will forever be blind to. We don't know. We can't know. And perhaps that is the most profound thing the James Webb Space Telescope has given us. Not the images, not the data, but the absolute, irrefutable confirmation that the universe is not something we can ever hold completely in our minds, no matter how powerful the telescope. No matter how sophisticated the model, the universe will always be larger than our ability to see it. The question is whether that terrifies you or whether it makes you want to look harder.